Okay, so I was going through some studies and just learning about AI and machine learning in general, what it is, how it works, like key principles, and decided to prepare this presentation and a little uh, overview about basics of machine learning to encourage other people in a company to start learning and to contribute to this topic. There is a big hype about AI nowadays after ChatGPT was released, and like everyone knows what AI is now. Like everyone's using it, or at least trying to use, and it's overhyped. Everyone is kind of, I think, know how it works, but I wanted to go a bit deeper and um, talk about key principles and basics of AI and in particular machine learning. That's why I did this little presentation, which will take probably 25 to 30 minutes to go through. So to talk about it and to try to explain how it works so you can take it from there and learn further on this topic. So what is our agenda today? We will be talking about what is machine learning, what is the difference between machine learning and AI, and what those terms are, what applications are for machine learning, a little history about it, uh, what types of machine learning main types there are, and what their purpose, and also what are problem-solving algorithms. We will look into a couple examples how these types or these machine learning algorithms can be used in real-world example. So let's start. So what is machine learning? Machine learning is a science which allows computers to learn without being explicitly programmed. So the general idea, like uh, the, let's say, standard programming or basic programming, is that when you create the algorithm for some program or application, it actually works uh, in scope of that algorithm that you do, like in a program, and it cannot learn or deviate from what it was programmed to, right? From the other hand, machine learning is an algorithm that learns as it runs. It learns on the data that it was processing to, and it can become more precise and better. So technically, it doesn't have to be programmed explicitly to do some things with data that it works on. So that's uh, technically what it is. And now let's look at the AI and machine learning, because I think there is also confusion about those two types, what AI is and what is machine learning. So AI, like artificial intelligence, it's a system that can be rule-based uh, or programmed, right? It doesn't have to run machine learning algorithm inside, uh, but it can be rule-based to accomplish some tasks, right? So it can use machine learning or cannot use machine learning and still be AI intelligent, system, artificially intelligent. Let's put it this way. From the other hand, machine learning um, is a system or algorithm that learns from data that it uses over time, right? So, and it also uses algorithms of patterns that can make decisions based off of data that it gets, right? So if you think about it, AI is like superset and ML is a subset inside of the AI. So AI can be rule based or ML based. ML is always, so it can learn, AI can learn or not learn from data that it actually processing, right? But uh, ML, machine learning, learns from the data that it is using, right? So that's a little difference right there. So what are the applications for machine learning that we know about right now and that are widely used? For those who live on another planet and didn't heard about AI yet, we'll go through this little example. Some cases might be not that obvious to you, uh, that you think of, right? So first is voice recognitions applications, right? Like, hey Siri, hey, like Siri, hey Google, all these things, they, you know, recognize what you're talking about, translate it to text, and then work with that text. So search for something, or, you know, so on and so forth. Ads proposals or ads, you know, on different social media, for example, platforms, Facebook, Instagram, YouTube, they all have underlying machine learning algorithm that learns about your behavior on the platform, what you click on, what you don't click on, what you like, you don't like, and they personalize ads that you see in based off of your behavior on a platform. So it learns from all the different users and then uses the data to, you know, to give you the best possible ad based off of your behavior. Search engines, right? So rankings, all these things in Google, they also use underlying algorithms, some kind of machine learning algorithms that understand what you like, what people are doing on a page, speed of the page, context of the page, all these things, and then give you the best results for the question that you are asking for. Spam filters, I think that's pretty obvious. Image recognition platforms. Also, we have a customer called QuaxAI. These guys are building tools that allow to write automated test cases without testers. So you run the tool on your, let's say, website. It understands what the page is, creates test cases for that page for different elements, inputs, buttons, you know, screens, and so on and so forth, and then automatically executes those test cases on the website. So you technically, they're trying to automate that flow even more than with regular automation. Medical disease recognition. So, for example, it's now machine learning algorithms being more and more used inside of medical facilities to help to recognize different medical conditions, to help to recognize like tumors and things like that. Copywriting, obviously ChatGPT, obviously, you know, all these tools that are flying around. Video editing software. So, for example, there are applications out there that you can upload the long video for like an hour, and it will cut it into 1 minute short videos for TikTok, YouTube, all these platforms without losing the context of the video. So you will cut it in short pieces in a way that that video makes sense, right? So it's a complete thought in 1 minute. Self-driving cars. So that's like Tesla, all these car manufacturing companies like Toyota, BMW, Mercedes, they all work on some kind of self-driving, Google even as well, self-driving car, or at least to the extent that it helps you to drive right now, but they are trying to reach to that level to be totally autonomous and drive on its own. So that's just a handful of different applications that can use underlying machine learning algorithms for your understanding how it can be used, right? So then let's move to a little history. The whole hype about AI came like what, year and a half ago when ChatGPT was released, and they got like first million users in a week or something like that. So there were some crazy numbers. But in reality, this ML algorithms and AI in general was long time on the market. It was just not that publicly available, so people didn't really know about it. But in reality, it was out there for a long time. So the first algorithm, ML algorithm that was built by Arthur Samuel in 1959, right? So what he did, he was trying to learn how to play checkers, right? Because he was not really good at it, and decided to train a computer to play against him and to be able to learn from a computer. So what he did, he created a program that would play with, the computer would play with itself. So one computer against another computer, technically speaking, and it would play so many different games that in the process it will learn which positions are better in checkers to do in order to win the game eventually, right? So it would not technically it would brute force all the combinations. So it will learn in the process, playing with itself, hundreds and hundreds of thousands of games, and learn which positions are better to put your checkers to in order to win the game, depending on what your partner is doing. So eventually, this first prototype of AI, right, or machine learning algorithm became so good that he could win any game that Arthur Saniel was trying to play with it, and any other people he knew couldn't beat that computer because it became so good in the process. So as you can see, this is a very, very old concept. I mean, not ages old, but from 60s. And it was developing in a science, more science community, and became popular just recently, well known to the public, because all these Google algorithms, Facebook ads algorithms, they were there for a long time. Data analytics like Aladdin, developed by BlackRock, was like 2000 or something, so like it's 20 years old. But it also analyzes stock data and financial data and predicts the results of the movement. So this concept is not new, just for understanding, but it was pretty much interesting to the small community of people that was working on it for what is it, like 80 years now, right? Or 60 years. Okay, so let's get to, when we covered, applications and basic stuff history. Now let's talk about different types of machine learning algorithms that are out there, right? So there are 4 or 5 of them, as I remember, but the main 2 types that are widely used in most cases are supervised learning and unsupervised learning. And today we will talk about these 2 concepts, what it is, how it's working, and what problems these types of machine learning can solve or help you solve, right? So let's start. What is supervised machine learning? Supervised machine learning is an algorithm that for every given X, input X, it has output Y, right? So it has X and Y as a technically bunch of training data, or in this case, right answers. So every X or every input has a right answer to right answer, right? So, and then when you run that algorithm, it learns from that input and knows what the output is. So let's say we have 100,000 records of some data that we run through the supervised learning algorithm. It learns from that data, so which X has which Y, X, Y, X, Y, and then when you add it 100,001 record of X, it can give you back predicted Y based off of data that it processed, before, right? Trained on. So that's why it's called supervised machine learning, because it always has some training data that it learns from, and then when it worked with the data, it can predict the result of completely new data set and give you a result, predicted result based off of inputs, right? So that's why it's supervised learning. So here is a couple examples to better understand what we're talking about. So let's say we have a spam filter, right? We will give it, let's say, 100,000 emails, which will be marked spam or not spam, right? It will work through that list, and then when we send it a new email, it will be able to detect if that email is spam or not spam, right? So that's example number one. Then audio speech recognition application, the same principle. It works with a lot of audio files and translations of those files, and eventually it is able to transcript audio to text. Same thing for online advertising that we were talking about earlier. It works with a lot of ads and user meta info, right? And then has an info if user clicked on that ad or not clicked on that ad, and it can predict or learn what users with certain meta info like or don't like, and then work with the new users based off of that data. Same thing for a self-driving car, right? They work with the images or cameras and radars from those vehicles, and then can predict positions of other cars, your car, speed, and so on, so they can drive on them on their own. So that would be examples of supervised machine learning applications and principles of how they are used. So let's go a bit deeper on this supervised learning, algorithms. There are different problems or subtypes that supervised algorithms have. And this is one of the examples. So let's say we have a graph here, right? On a vertical, we have thousands of dollars for the house price in thousands of dollars. And on the horizontal line, we have a square meters of that house. And our goal is to predict how much, how much I can sell my house for based off of historical data or based off of training data, right? So let's say, I know it's not that many records, but it's to illustrate how that thing would work, right? So let's say we have this graph, right? And with the stars, you can see the prices of certain houses on this graph, right? So the bigger it is, the farther it is from the left. And the goal of the algorithm would be to write a function, right, that can predict a price of the house. So let's say I have a price. I would like to know the price of the house for 200 and I don't know 75 square meters, right? Or let's say 280. So it will be somewhere here, and according to our graph, the price will be something like what 225 or something. Thousands of dollars, right? So in order to predict the price, we can design a function, right, that will be predicting a price depending on the test data that we have. And it can be as simple as this, right? So just a straight line. So we have some values that go up, some values that go down, but on average, it's a straight price. But if we do it this way, then the price of the house of 200 for 270 square meters will be around $230,000, right? But in reality, it is 200, almost less than 200,000. So if we do it a straight line, the from the actual data will be, pretty far, right? So our goal as the goal of the person who develops machine learning algorithm is to create a function that will describe a data that's coming as a test data as close as possible to the real data that is there, right? So it shouldn't be a straight line. It might be something like a bit here or down here or like curly line, something like that, right? In that case, the new data that we will get will be closer to the reality than than just a straight line, technically. So this problem is called regression algorithm. And the idea of the regression supervised algorithm is to predict a number out of infinite number of possible, infinite combination of possible numbers. So what I mean by that is that we need to, for the price of the house, let's say 301.5 meters, we need to be able to figure out how much it's going to cost, and it might be something like 250,121 bucks, right? So there is infinite number, infinite values in that bucket, and we need to predict y by x. That's what's called regression algorithm. Different type of supervised algorithms are classification algorithms. So in this case, classification algorithm in this case can have only two values, 0 or 1. And what we're trying to do is to figure out if a tumor on a picture, right, is a cancer or not, depending on its size. So on down here we have a size in centimeters, so 1, 2, 3, 4, and so on. And here we have either 1 or 0, right? Depending on the size, we are figuring out what is this a tumor, like a cancer tumor or not, right? And as you can see, on 4 or 5 is not, but 6 already is, and then 7 is also not. So if we have a number, let's say 5.5, right? So then algorithm should decide if it's a tumor is a cancer or not cancer. So it can have only two values, one class or another class, right? So that's this problem solving is called classification algorithm. So it can classify which y is this depending on x that came in, right? So that's the one. And then classification, we will look a bit deeper into that tumor size example and try to understand how to build a function that will predict result using this chart. So the idea here is that circles are tumors that are not cancer, right? And crosses are the tumors that are cancer. Then on the bottom, we have the same sizes, 1, 2, 3, 4, and up till 10. And here on the y axis, we have an age, right? So now we have more than one input to the same problem. And inputs can be as many as you want to. It can be like color, size, whatever, right? The more inputs you have, the more predictable the output will be of that algorithm if you train it on that data. But in our case, we have two inputs. One is the size, second one is age, right? So as you can see, let's say 3 and 20, if we're trying to predict that if it has size of 3 and you're 20 years old, it's not cancer, right? Like it would predict not cancer. So our goal, but you can see also that there are some cases where when it like it's very on a far, right? So you can see that all of them are grouped here. So even older people with a small size, it's not cancer. And then, the bigger size and the older you are, the more it is, right? The more probability. But there is also some results that are coming outside of that schema. So if we would try to build a formula or an formula to predict results based off of this data, we would need to build it in a way that would do a line that would look something like this, right? So it's a curved line, which means that everything that is on this side, it's not, it's not cancer, this tumor, and everything that is on that side is tumor. So it would build it, so that algorithm should follow this line, based off of data, and then when you put the new data in, it will, be able to predict the result. So that's a, classification problem with two inputs in this case, but it can be more than that. Okay, so let's try to, finish on this supervised type. It's not all of them, this regression and classification, but these are two most widely used algorithms out there. So there are two main algorithms for supervised machine learning type. One is regression, right? So that's what we saw at the beginning, that you need to predict a number out of infinite, many possible, numbers or outputs. You need to predict one. And then second classification algorithm is you need to predict either this output is class 1 or 0, right? Like either this one class or another class, can be more than two, but it's, it's a fixed number of outputs that this algorithm can produce. So 1, 2, 3, 4, 5, for example, right? But it's a small set of possible options that you can decide what to choose from. So that's supervised algorithm. Now we'll go to another type, which is called unsupervised learning. So that's another set of algorithms that are widely used in machine learning and in computer science, let's put it this way. So the purpose of unsupervised machine learning algorithms is to be able to figure out some dependency of a data that human cannot figure out. So this data for unsupervised learning algorithms only comes with the inputs, right? But it doesn't have any outputs, so it just access. And the purpose of that algorithm is to find a structure in unstructured data that it gets. That's the, the goal. I know it might sound a bit, complicated, but we will try to see a couple examples, and I think you will understand what it is, and then we can it will be easier. So let's put it this way. As in supervised algorithms, there are two types here. Like it's we will talk about three types of main types, I would put it this way, of unsupervised learning algorithms and their purposes, how they can be used, so you can understand what is it. So one, that's what we already kind of briefly talked about, it's clustering. So technically it groups similar data points together and creates clusters of data. So it takes the unsorted amount of data, tries to understand some dependencies, and clusters that data in groups. Where this can be used. For example, if you want to create customer segmentation in your store, right? You have a bunch of customers that buying something in your store, and you want to understand, like, for example, how, what products are bought in certain region better and which are worse, right? So you can give it customer data, products they bought, where they are from, their location, let's say age, whatever, any other customer information, and it will produce you a clustered data by region, for example, right? If it finds that dependency, so you can understand what people in that region buying, why they buying, like what age groups, and so on and so forth, right? So if you want to do some clusters on a big data, this why these algorithms are for, to clustering unclustered data. For example, it also can be used to cluster human genes, right? So it takes different gene types of different people and trying to understand some dependencies. I've seen an example where people were able to figure out from the human, gene array, which people are liking certain products and which are not. So figure out genes that are responsible for you liking milk or you don't like milk, for example, right? Then the second type is anomaly detection. So it finds out unusual data points in data array. A classic example is bank fraud, right? So if you are withdrawing every month, let's say 5,000, from your account, and then today someone's trying to withdraw 100,000 from your account, this transaction automatically blocked because it's unusual, anomaly detection or unusual behavior of you in that bank. So algorithm figure out that this is something wrong, and it just prevents it and blocks it. It might be wrong, you just decided to buy something fancy, but that's its purpose. And then the third group or type is dimensionality reduction. This set of algorithms are used to compress data, right? So it can figure out which data is redundant, remove it without losing the quality of that data. So that's can be used for compressions, for compress some data, then uncompress it later if you need to store it somewhere, and things like that, right? So let's see some examples of unsupervised learning, algorithms. And in this case, it's clustering. So this morning I just went to Google, news website, entered jobs AI, and it gave me a list of articles that are related to these two words. And you can see I put them in red, that these two words are in every article, but not always the same. I mean, it's not always jobs and AI together, right? So it can be in different sentences, but it's all are there. So how it works, Google crawls the news websites, indexes all the data, and cluster it by different words. And then when you enter, your search request, it actually goes to that data to index, finds those clusters, and give you back, all the articles that are related to the words that you actually enter in a search bar. So that's an example number one of unsupervised learning. Example number two is what we were talking about earlier. Let's say this is some customer data, right? So it's just a bunch of data with different data points, right? And we need to figure out what is what and what are the clusters. So when you run it through clustering algorithm, it will provide something like this. We have one cluster, second, third, blah, 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 and then centers of those clusters. So now we're working not with a bunch of garbage or unusual thing that is there, but with the groups or clusters of data. And now we can even go deeper and use those clusters to clusterize them again to get to the specific information that we are looking for. In our case, in my example, it was your customers on the store. So for the store like Amazon, for example, right, with billions of customers, it will be hard for them to manually figure out who's buying what, why, and so on. So they have these algorithms behind which cluster data, help them to predict which products will be bought next month, who's buying what are trends. I've even heard a story that what they do, that Amazon is a marketplace. They let, people sell their things, online, and they can just deliver them. But if they see a trend through their learning algorithms that this product is being sold a lot, they just, create their own product from Amazon that is exactly as the one that is trending and trying to, compete with the seller that is selling on their platform. So that's an example of clustering, in this case, of customer data. So I didn't want to put this presentation too big. There is much more on this, how to write those functions that will predict the results. What is the error functions? all the different kinds of algorithms and how to use them. But I didn't want to put everything into one presentation. That's why I call this one Basics, to explain basic concepts of the machine learning and a little history behind it. And then, we can continue on the next tech talks. Maybe someone will take it over from me on this topic if it will be interesting.